without further ado, it's my pleasure to introduce you Doğan Fennibay. He's a principal key expert at Siemens, specializing in automation and system architecture. He has a deep expertise in industrial building automation, and he focuses on advancing the transformation of the automation system in IoT era, of course, thanks to the open nature of the web. So it's all yours. Go ahead.
Hi, colleagues. My name is Doğan Fennibay. I will be talking about how we brought Web of Things and BACnet together. I like to start with maybe the like how does our system look like, right? So this is typical, maybe rather large scale example of a building or excerpt from a building. So what you see here is we have these field bus protocols at the bottom. Yeah, so we have the field bus protocols, right? These are various. And then in the middle, what I call management layer, or you could also call it control layer. So between our controllers and the management platform, management station, and other controller to controller communication, this is where BACnet is used. And nowadays, of course, we have cloud, Building X in the Siemens offering. And there we have the cloud integration, which is using other protocols, not BACnet directly. So here, basically, of course, we have to start. Why do this? Why bring in Web of Things, right? Because BACnet, I will talk more about it, has a market share of 77%, which is very impressive. So why do we need to bring something else? So this I like to little bit clarify. So one thing is we see more and more IoT integration. This is increasing. So that means new apps, so cloud apps, web apps, edge apps coming into the buildings domain. And they like to have something like a web-like paradigm to work against and not some specific protocol in the building. Another thing is these specific verticals, or like the integration of the building into the energy grid, for instance, or like where BACnet is not used, or integration of course data centers vertical is a hot topic, of course, right now. And there we see different standards, different domains, and they don't have a direct integration path to BACnet. And this is where actually this web-like approach or bridging BACnet with the web using Web of Things really helps. Smart peripherals, so this strict layering of the field management control and the cloud, this is also kind of disappearing because some peripherals, they get some control functionality, right? And then they also want to participate in the control loop. So they also want to talk BACnet, or they also want to talk other protocols. IP everywhere is more and more increasing. The push for IPv6 is there, of course, and then we are going away from the serial protocols towards more IP-based protocols. That is also changing the landscape. Essentially, the high-level picture is we are transitioning from the automation pyramid to what I like to call the IoT hourglass. So with a narrow waist, and then with a large southbound and northbound ecosystem. And of course, not to forget, cybersecurity and zero trust is coming, and there we cannot have silos. This is the solution for this protocol. This is the solution for that other protocol. So the message is we need to keep the power of BACnet, which is quite big, quite strong, and we need to extend it with Web of Things for 100% openness and integration. So that's where Web of Things comes in. So it's very simple outline today. I will talk about BACnet briefly. I will talk about Web of Things briefly, but maybe I don't need to for this group of audience. And then I will talk about how we did the Web of Things BACnet binding. Christian already gave me a very nice reflection. So just I am Doğan Fennibay. I work as a principal key expert for system architecture and core assets in Siemens Smart Infrastructure buildings, mostly in the comfort applications, so HVAC and lighting applications. My interest areas, so feel free to reach out to me if you'd like to discuss any of these topics or maybe something else. I would be happy to discuss. So, okay, now let's talk about BACnet. So it's a communication protocol specifically targeting building automation. It has an application layer, a network layer, and it supports multiple data link layers. So it is already doing a lot of stuff like in terms of discovery, routing, handling message fragmentation, and also in the application layer, allowing confirmed, unconfirmed messages, state machines, change of value services, etc., etc. So it establishes already an inter-network that can be multi-data linked with routers and all that stuff. It provides object types for application interoperability. So there are data point types, domain-specific types like schedule, calendar, elevator, etc. There are also some infrastructure types. I call them infrastructure. What does it mean? The automation infrastructure in terms of the devices, their network ports. You can even do file download, upload, and all that functionality. And it can be extended with proprietary extensions by the vendors. This is also regulated how this can be done. Ecosystems, it is hosted by ESHRI, the standard number 135. It is also an international standard. And it has also a certification process and test labs where you can get a logo for your devices. The market impact, I mentioned 77%, right? It is very impressive. If you see the graph on the left, in the North American market, which is not a small market in the buildings domain, it has a market share of 95%. So this is very impressive actually for any kind of protocol in any kind of domain. Further numbers are like, if you look at the BTL listings, like how many products were certified, like close to 1,500 products from 233 manufacturers, 1,500 vendor IDs assigned. There are some alternatives just to understand like what is this remaining part of the 77%. It is OPC-UA if it is mixed. It can be Connex in the Europe. You see in the smaller buildings, maybe that. I don't want to go into political discussion here, but they exist, of course. For lighting applications, there's DALI. If you go to smaller end, of course, home automation is not the place where you find a lot of BACnet. Of course, there you find Apple HomeKit and Matter, etc. is coming up. But the key message is BACnet is irreplaceable in the buildings market. We have to be aware of that. History is it was started in 87, so it was a US effort. 95, the US standard was published, and since 2003, it's an international standard. By the way, I cannot see if you are raising your hand because of my screens. Maybe we take the questions at the end. I hope everything is clear until then.
Yeah, we will take the questions at the end. Yeah.
Okay, thank you. Mm-hmm. So the Web of Things, I don't need to explain much, but maybe what's interesting for you is how I see it or how we see it. So how I see it is there's this IoT fragmentation problem, meaning we onboarded lots of southbound systems to lots of northbound systems, but because there is no common abstraction layer, these are all one-to-one integrations. So if I engineer an app like this, it has to understand the complete complexity of the whatever field protocols are out there, whatever different vendors are out there, different kind of devices are out there, which doesn't really scale. Like a good ecosystem, be it the internet or be it, I don't know, an operating system with its drivers and applications, has to have a narrow waist. And this is the promise of Web of Things, how I see it, which is what you see here in the middle, the properties, actions, and events. That's this unified interaction model, a common interaction model, whatever protocol, whatever vendor it is. It is domain agnostic, so Web of Things doesn't contain anything specific about buildings, so this we have to extend on top. And it is very lightweight. So it's not like if I would print out the Web of Things specification, it wouldn't be 1,000 pages. It's a very lightweight standard, and it is it refers to existing web standard. It doesn't reinvent, right? For instance, for data model, it just uses JSON. For URI syntax, it just uses existing RFCs and so on, which I actually quite like, and which also makes it very friendly to web developers. Why Web of Things? What are the alternatives? Like again, I see some vendor-specific standards, some protocol-driven data models, and some consortium-driven standards. And consortium just tells me it's not one vendor, but a bunch of vendors. And in comparison, Web of Things is driven by a neutral entity, so World Wide Web Consortium. It is lightweight and it is well accepted. So that's why so far we are working with Web of Things and we are happy with it. This is the reason why we choose Web of Things. Now I'm going into Web of Things BACnet. Why are we doing it? And maybe it's best to start with some use cases. So on the left, you see a simple case. I have an actuator which talks BACnet, right? And I have a thing model. The blue things are the thing models here, meaning representing a type. And then I instantiate it by adding this instance-specific information like BACnet device ID and maybe other things. And with that, this thing description is enough to describe that device for a building management system. You can say SCADA for buildings, which is like in our case, it would be DiscoCC. And then it can talk to BACnet. Or this actuator is maybe working with a controller together, and then maybe I'm not importing the thing description directly into the controller, but into a tool. Then it understands what this device can do, what are its properties, actions, and events, and then this controller can work with that BACnet. And of course, the cool thing about Web of Things is, if I have a similar actuator not using BACnet by Modbus, maybe from a different vendor, whatever, I can have a similar thing model and I can repeat the whole process in a very similar fashion, except the protocol specifics, of course, but everything else is common. On the right, you see a slightly different use case. I can have a controller, and that controller is a freely programmable controller in this example, meaning I cannot really create a thing model for that because I don't know what it will look like. It depends on how the user programmed that controller. So here, actually, I rely on my tool that creates thing description representing the specific capabilities of that programmed controller. And this I can use to onboard it into my on-premise building management system or cloud-based building management system or edge. And same thing, I can also use it for a controller. So it's like this cool thing is it's always the same description I can use for multiple purposes. And that's the cool thing about Web of Things, this narrow-based and always the same description. I don't need to reinvent it for different scenarios. Now let's come to like how it looks on the inside. So what we need to start is we need to look at the domain model and we need to layer it properly. I will start in the middle, which is what you see in the interaction side. I said it now, I think, multiple times, property action event. This is how I model my device, right? It has these interactions, the interaction affordances, they have a data schema, of course. So this is how we handle it with the JSON primitives. Is it an integer? Is it a Boolean? Is it a floating point? What is minimum, maximum, unit, and all that stuff? We can model security here if the device offers some security features, and then we bring in the protocol. So all this, we consider that's the IoT domain, right? So this is nothing to do with buildings yet. But on top, we need to extend it with the building specifics. So this is one side is the classification. Classification is like, am I talking about the set point or is it the sensor? Am I doing something about heating or ventilation and cooling? So that would be the classification of this interaction, which is valuable for lots of northbound applications. And on the other side, we have the structure information. This is again domain specific. This is like, what is your building structure? What is your equipment structure? What is your network structure? And you can also imagine different kinds of structures based on the automation system. So this we extend on top of Web of Things using different models. Now I come to solution domain. Sorry, I was a bit too fast. For the IoT domain, we use Web of Things. For the buildings domain, there's actually more than one standard. So brick and real estate core is definitely, we are looking into that. We have also offerings that work with Haystack, but at the same time, we have a large portfolio with Ashby 223P and connects. It also has an information model. And if you go out there, you also run into proprietary models for that. But we try to stick to the public standard building models. And all this is peripheral. The focus of today is actually what we do in this layer in the protocol binding for the Ashley protocol binding. So now I scoped it, and now I can talk about the content a little bit. So this, in 2022, we started this work with Klaus Hartke and Michael Koster. I think they're in the call. And then in March 2023, we released the first product, which was before we published the first draft. That can happen during these things. October, we published the first draft where we supported read, write, observe operations. And then in March, the next year, 2024, we made the second release in our products. And of course, because we released before the standard, the draft was published, we had to do some adaptations. We had to take care about the compatibility, impact, and so on to our product. But it's okay, we handled it. And in July last year, we published the eventing part. And of course, the small fixes and improvements, it never stops. We keep working on that. On the mindset, so how we worked with Klaus and Michael is like, we said, first of all, less is more. For instance, like it was never about modeling the complete BACnet, right? Because BACnet is a huge protocol and we don't intend to model the whole thing. There is like good implementations of BACnet, good certification processes, etc. That is how it is. The value was establishing Web of Things interoperability. For instance, I think from 2012 or so, there's a BACold ontology, which is, I think, its value. And it's a huge ontology. It contains almost 18,000 triples. In comparison, our work is just 174 triples, which is by intention. So this is not intending to do what BACold is doing. We are just doing the interoperability layer to Web of Things. We proceeded in a less is more fashion also for use case driven. For instance, we looked for the eventing model. We didn't, BACnet can do a lot. For instance, when you are subscribing to the events, you can specify which days of the week you want to receive events, as an example. But we made a survey. None of our clients and non-typical building automation client doesn't really use that. So we said, okay, let's not model it yet. We can add it later to keep it simple, right? It can definitely be extended later when we have the concrete need. And we also left the data link layer specifics out because, as you saw, data link layers, and there is no value in modeling them because once I have the network layer device ID, then I can do the addressing and identification of my device. In the spirit of Web of Things, we did not reinvent existing things. So for instance, the URI syntax is actually borrowed from the BACnet standard. There was no value in reinventing it. And we also had a clear opinion for web, meaning like BACnet, of course, has a history that dates back to the 80s. And there we tried to push a little bit towards web. For instance, BACnet uses timestamps in a certain format, and it's based on the centiseconds, right? It's 100th of a second. And here we just chose to use the ISO 8601 timestamp. So that's sort of opinionation for web. Now I'm coming more to the content. So first of all, in BACnet, we have objects and properties. So on the left, you see an analog input object that represents a temperature, for instance. And these things, you see the present value, units, etc. These are the so-called BACnet properties. In thing description, we also have something called a property. But we should not come to the wrong conclusion where we say a BACnet property corresponds to a thing property. No, actually, it's a little bit, how do you say, shifted. A BACnet object corresponds to a thing, a property affordance. I didn't mention it before. Essentially, this is about how our clients conceive a data point. So this temperature would be a data point. And if you look at the details, it makes a lot of sense. Because what we see on the left, for instance, with the units, minimum present value, maximum present value, these map one-to-one to this unit minimum and maximum you would find on a property affordance. So that's how we did it. Here we make some sort of categorization where we say, okay, there are static attributes and dynamic attributes. Static meaning they don't change during runtime. They change when somebody changes the configuration, maybe at commissioning time. So these can go into the thing description because thing description is rather static, right? But the thing itself, the value of the temperature, of course, is dynamic that changes at runtime. And among static attributes, we have standardized like minimum, maximum units. And then we have the not so standardized. These are domain specific attributes. And here you see, I think here I just used the terminology from Haystack, but if it would be different if I was using Brick, for instance. And this we model also in in the thing description as custom attributes using the context extension mechanism of thing description. Then we have the dynamic domain-specific attributes. These are what we call, they are not points by themselves, they are point attributes, like reliability, out of service. So these are also in turn modeled as property affordances because they also have all the things that you would find in terms of a data model, like enumeration or minimax and unit and all that stuff is also there. So this is how we map it, which makes sense because if you go one level up, if you have a room sensor, that can correspond very well to a thing in the sense of a device or peripheral, or as I was saying, it could also be a software-based functionality like a control program, but in this case, it's just a sensor. And this is a convention, by the way. We don't force this. If you need to map a certain BACnet property to a thing property, this is possible because we allow this in the URI syntax. I think I will come to it in the details. And now I come to the details. So here I like to switch to the web page. So the things I want to talk about is not much because I encourage you to have a look at it later. First of all, the URI syntax, it is extensively defined here. I think this was Michael's work mostly. I just jumped to the examples that's easier to consume. So basically, this is how a URI looks like in BACnet. It's based on the BACnet specs Annex Q8. So we made some small changes to it, but not big in the URI variables, exactly in the examples. So basically, it's the device ID first, and then something to indicate the object ID. This is divided into object type and object instance number. And then this part is optional. You can also specify a property. This is what I was saying. So we are not forcing to map a property or an object to a thing property always. If you need to map something directly to a point, you can specify the property ID and then you have the complete freedom. So we were careful not to make it too constrained. So that's the URI syntax topic. URI variables are, we specify some URI variables. And the reason is, for instance, in BACnet, we have a mechanism called commanding. Commanding is in a building, what we have is we have the multiple writers problem often, because in a building, lots of things happen at the same time. Like it can be that the normal operation is running. For instance, I'm now in a meeting room, and then I want to maybe change the set point for the temperature here, which I actually did. But then there's a schedule which sets the optimal room temperature. But it can also be such that maybe a service guy or gal comes in and wants to also stop an actuator from operating because they need to clean it, or because of some other reason, like for instance, we need to prevent condensation, to prevent water damage to the equipment, and that also kicks in. So there is something like a priority order, like the economizing option should be less important than my comfort, and my comfort is less important than equipment protection. So that reflects itself in terms of when I'm writing, I need to sometimes specify a priority for this writing. And we decided, or we discussed, okay, let's do it with actions. But if you do it with action for the same point, when you are reading from another interaction affordance, and when you are writing to a different interaction affordance. That doesn't make sense. So we needed something that I can read from the same thing and write to the same thing, but I need to specify a priority when I'm writing. And there URI variables were actually a very nice match. So when you are writing, you can specify a command priority as a URI variable, and along with your the value that you want to write, and this we can translate to BACnet very nicely. So I think this was a quite good story. On the events, so that's the URI topic, URI variables topic, and maybe on the mappings. BACnet has a very extensive data model, so you can have a lot of things. It's based on ASN.1. If you know the certificate encodings a little bit, it's the same underlying mechanism, I would say. Here the point was, how do we map this to a JSON world? And here you see like the BACnet specific types, how they map to Web of Things data schema. The takeaway for you is following: often, or like actually always, the JSON model that you specify in the data model is good, but it's not sufficient for BACnet encoding. For instance, here you see a good example. You can have a number in JSON, but in BACnet, sometimes it is encoded as real, and sometimes it's encoded as a double. So that's like a single precision, double precision story, right? And this you need to specify in the BACnet form in order to have a proper interoperability with the BACnet device you are communicating with. And you can do a lot of things. Please check it later if you're interested, in terms of like mapping arrays, mapping objects, mapping complex types, mapping variants, so one-off, etc. This is all possible. Please check it on your own time. Events is quite a big portion, but essentially what I want to say is, in BACnet you can subscribe not to a data point directly, but you always subscribe to a notification class. There we modeled notification classes as event affordances. So you subscribe to them, and then out of those notification classes, you get the events. The events that you receive will contain the actual event sending object. Everything is detailed. Maybe I just pique your interest and stop there. That would be maybe a good idea for time management. Yeah, and we also used action affordances to get for alarm synchronization purposes. So this is like, I wasn't subscribing yesterday. I want to know the alarms that are active since before. Then I use the get current events action affordance. And there's also an acknowledge event process, and there you can use the acknowledge event action affordance. Now I switch back to, yeah, so what are the next steps? Now I learned the colleagues set up a bindings registry. I checked with Ege that first they will do it for HTTP and then we will follow. We don't have a registered IANA scheme for the URI that I showed. It is specified in the BACnet. Here the point was, I mean, BACnet didn't have it registered in IANA, the one that they defined. So then we didn't feel in position to do it on behalf of Ashri. So we need to check with them. Potential, like now 2.0 is coming, so we need to check potential adaptations. And further is this an explicit model for the point attributes, and also BACnet has something for time series, so there you can have point time series and alarm time series, trend log, event log. These are things that we are looking at, but if you have maybe further needs, feel free to ping us, and then we will try to address. And now I think I'm at the end. These are the links if you'd like to reach out, and now I think we can open the questions.